Hello, everyone. Today, we're going to talk about a super practical tool in math called linear programming. Now, I know the name sounds a bit heavy, right? But don't you worry. Just think of it like the ultimate strategy game, where your goal is to make the best possible decisions to get the highest score. So let's jump right in. Think about any game you play. You've got, say, a limited number of skill points or a fixed amount of gold to spend. How do you decide what to do? You've got a plan, you've got to strategize, all to build the most powerful character possible. You're trying to max out your stats with what you have, right? And hey, it's not just in games. This is something you do every single day. Seriously, think about it. You're trying to squeeze the maximum amount of fun out of your limited pocket money. Or you're trying to get the best possible rank by figuring out how to divide your limited study time. All of these are real-life strategy puzzles. Now, to really get a grip on this, let's take a classic problem straight from your textbook. It's about a furniture dealer. I promise, after we break this down, the whole thing is going to be crystal clear. Okay, so let's meet our main character. He's a furniture dealer. And here's his first problem: his budget. He has exactly 50,000 rupees to invest. Not 1 rupee more. That's his limit. And that's not all. He's got a second problem: space. His go-down, or his storage space, can only fit a maximum of 60 items. So even if he had all the money in the world, he just doesn't have the space for more than 60 pieces of furniture. So what can he actually buy with his money and space? Well, he deals in just two things: tables and chairs. As you can see, a table costs him 2,500 rupees and he makes a profit of 250 rupees on it. A chair is much cheaper. It costs 500 rupees and gives him a profit of 75. So, this brings us to the big question, the main mission. With his limited money and limited space, what is that perfect combination of tables and chairs he should buy to make the absolute maximum profit possible? The special math tool that we're going to use to solve this puzzle is called linear programming. It's basically a super powerful method for finding the best result in any situation that has clear rules and limitations, just like our dealer's problem. But before we go deep into linear programming, let's just zoom out for a second. The dealer's problem is a type of problem called an optimization problem. And the name kind of gives it away, right? It's any situation where you're trying to find the optimal or the best result, whether that's maximum profit, minimum cost, or highest score. So a linear programming problem, or an LPP, is just a special kind of optimization problem. Now, what makes it linear? Well, it's because our goal and all our rules can be written down as straight-line equations or inequalities. If you were to draw them on a graph, they'd all just be straight lines. Simple as that. Okay, let's be honest with each other. A lot of the time, the hardest part isn't the math itself. It's turning the word problem from English into a proper math model. But trust me, it is so much easier than it sounds, and we're going to do it together, one step at a time. First things first, we need to figure out what are the things we actually need to decide. What do we have control over? In the world of linear programming, we call these the decision variables. So for our dealer, what does he actually need to decide? It's simple, isn't it? He needs to decide how many cables to buy and how many chairs to buy. So let's just give these decisions a name. We'll say X is the number of tables and Y is the number of chairs. Easy. Okay, variables are set. What's next? Well, now we need to write down our main goal using math. And this has a fancy name. It's called the objective function. Now, objective functions sound super technical, I know, but it's not. Just go back to the game analogy. It's the score that we're trying to max out. For our dealer, that score is his total profit. That's his main objective. So, how do we write this down as a formula? Let's build it. The profit from one table is 250 rupees, right? So the profit from X tables is just 250 times X. And the profit from one chair is 75 rupees, so the profit from Y chairs is 75 times Y. His total profit, which we'll just call Z, is simply 250X plus 75Y. Our whole objective is to make the Z as big as possible. Great, so we have our goal. But wait a minute, we can't just buy 1,000,000 tables to get infinite profit, can we? We have rules. We have limits. In linear programming, we call these limitations the constraints. And that's all constraints are. They're just the rules of the game. You know, just like you can't spend more money than what's in your wallet, our dealer can't go over his budget and he can't store more things than his go-down can hold. Let's translate the first rule, the money. The cost of x tables is 2500x. The cost of y chairs is 500y. The total of these two must be less than or equal to 50,000. So we get this. 2500x plus 500y is less than or equal to 50,000. Now, that equation looks a bit big, doesn't it? Let's clean it up. We can just divide the whole thing by 500, and that gives us a much friendlier equation. 5x plus y is less than or equal to 100. So much better. All right, next rule, the storage space. This one's much easier. The total number of items is just the number of tables, x, plus the number of chairs, y. And this total can't be more than 60, so we get a nice, simple inequality. X plus y is less than 60. And finally, there are two more rules that are, well, they're just pure common sense. The number of tables, x, has to be 0 or more. And the number of chairs, y, also has to be 0 or more. I mean, you can't exactly go and buy -5 chairs, can you? So we call these the non-negative constraints. And that's it. Just like that, we've done it. We've translated that entire English story problem into a neat and tidy mathematical structure. So let's put all the pieces together and look at our final mission blueprint. And there it is. Look at what we've built. This is our fully formulated linear programming problem. Our objective is to maximize z equals 250x plus 75y, and we have to do it subject to these rules, these constraints. We have successfully turned a real-world puzzle into a math model that's now all ready to be solved. So let's do a super quick recap of what we just did. We started with a story problem, we figured out our main goal, and that became our objective function. We then found all our limits, and those became our constraints. And just by doing that, we took a story and turned it into a clean, clear math problem. This whole process of setting up the problem is the absolute first and most important step in linear programming. You've done the hardest part. Well done.